The purpose of this video is to go over some questions from 5.1, 5.2, and 5.3 from MyMathLab. First question we're going to look at is number 7. And going through this question, we're really using college algebra techniques to calculate the area underneath the curve of a line that's given. So I just kind of blew this up here to see. We want to calculate what you did here, the displacement of the object from 0 to 2. So from 0 to 2, I'm finding this area. And I can break this up as the area of the triangle, which is 1/2 base times height. So this area would be 10. And then the area of the rectangle, which would be base times height. So this would be 20. So we have 10 plus 20, which is 30 here. The displacement of the object between 2 and 6. So now I'm looking at the interval from 2 to 6, so I'm calculating this area. And I could say this distance is 4, this height is 10, so the purple shaded area would be 40, and then I could calculate the blue shaded area as 2, and this distance would be 20 minus 10, so this would be 10. 2 times 10 would be 20, and then I have this triangle here with a base of 2 and a height of 10, so 1/2 base times height would be 10. So if I add up 20 plus 10 plus 40, I would end up with an area of 70. So we have a base of 4, height of 10, base of 2, height of 10, and then so we would have 70 meters. D, part D, would be use geometry to find the displacement between 2 and 6. Oh, that was C, sorry. Assuming the velocity remains 10 meters per second for t greater than equal to 6, what is the displacement between time t equals 0 and time t goes to whatever t would end up being out here for some t value? So we've done the work from 0 to 6. Now we need to find a formula that was going to be the area for when t is greater than 6. So for t greater than 6, I would have the height to be 10 meters per second. The length would be t minus 6. So if t was 10, then I would be 4 over 6. So I'd have 10 minus 6, which would be 4. So this would how I'd go calculate the length there. So if I wanted to find this formula, I would have 30 plus 70, which would be the integral from 0 to 2, plus the integral from 2 to 6, plus 10 times t minus 6, where the t is some value greater than 6, or equal to 6. So I would have 100 plus 10 times t minus 6. 5.2 is using geometry to calculate the integral. And so on this question, you have to pick the right graph, which you did. And then looking at the graph, we're going to use geometry to calculate the area. So keep in mind, if the function is below the x-axis, this area is negative, right? So 1, 2, 3, 1, 2, 3, 4, and then all the way up here. If I plug in minus 6 into the function, so I'd have 2x, so I have 2x plus 6. If I evaluate the function at minus 6, I end up with minus 6, so this point here is minus 6, minus 6. This is the graph of y equals 2x plus 6. If I plug in the lower bound, that gives me that this distance is 6, this distance is 3, this distance is 4. If I plug in -1, or if I plug in, sorry, 1, then the value of the output is 8. So then this height would be 8. So the area is going to be 1/2 6 times 3 plus 1/2 4 times 8. But one thing to keep in mind, that this area is negative. So I need to put a negative out front. So 6 times 3 divided by 2, this would be -9 plus 16. So I'd have 16 minus 9, which would be 7. So the value is the area underneath the graph is 7. I don't know if you answered 16 if you were just looking at this triangle. But since if it wanted displacement, you would actually take the absolute value of each one of these and add it together and have 16 plus 9. But it's not asking for displacement, it's asking for the area underneath the curve. And you have to take into account the area underneath the x-axis is negative. This example use geometry and not Riemann sums to evaluate the definite integral. Sketch the graph of the integrand and show the region in question and interpret your results. So we're looking at -3, the absolute value of x. So if we take the absolute value of x and flip it about the x-axis, and then we multiply it by 3, we get this function. I can always plug in my lower bound. So if I plug in -2, this distance is 2, right? If I plug in -2, I get -3 times the absolute value of -2. So that's -3 times 2, which would give me a -6. -2, comma, -6. So that tells me this distance is 6. If I plug in 3 into the function, I would have a -9. So this would be 3, comma, -9. So this distance is 9. So the area is going to be 1/2 6 times 2 plus 1/2 3 times 9. And then if we take into account, these are both negative because it's below the x-axis. So 6 times 2 divided by 2, this would be -6 plus 3 times 9 divided by 2, which would be a -27 over 2. 27 over 2 plus, sorry, -6 minus 27 over 2 would end up with -39 over 2. Which would give us approximately -19.5. Well, sorry, not approximately. It would give us 19.5. Use geometry to evaluate the integral. So I've seen a problem like this come up on the final exam, and a lot of times you can use the fundamental theorem of calculus. However, the fundamental theorem of calculus, the power of it really fails here because you have to do quite a bit of work to get rid of this absolute value. But if we were just to graph the line y equals 2x minus 4, so I could plug in some points, or I could say, okay, this is the slope of 2 and it goes through the point, the y-axis at -4. 4, and then it has a slope of +2. So I go up 2 over 1, up 2 over 1. So if y is 0, then 2x minus 4 crosses the x-axis at the point 2, 0, and this point is 0, -4. Right. So I can easily graph this line using whatever technique I want to use. I can plug in points. The absolute value means it's always positive. So I'm always above the x-axis. So if I was to graph the absolute value of 2x minus 4, then I'm just going to reflect it here. So this point would be 0, 4. And I can plug in my points. If I plug in 1, I have 2 minus 4, which would be a minus 2, but that's positive because it's the absolute value. So this point would be 1, minus 2. And then if I plug in the point 6, I would have 2 times 6 minus 4, which would give me 8. So if I plug in this point 6, 8. So I have two triangles here that I'm calculating, right? This triangle has 1/2 base times height plus 1/2 base times height here. So I end up with 1 plus 16 for an area of 17. So just remember on the absolute value, you got to see where the function is negative at, so where it would cross the x-axis. And on a line that's relatively easy to do, you plug in when y equals 0 and solve for that x point. And then you just reflect that line about the x-axis. You find your endpoints, and then you're only dealing with triangles. So you find the area of one triangle and add it to the area of the other triangle. Number 15 is kind of giving you the idea of integrals, but breaking it down into different parts. So if I'm integrating 2 to 4 of 8 f of x dx, what do I know here? If I want to go to 2 to 4, I have to end up going can I go, what do I know? Consider two functions on 2 to 9. We got 2 to 9, 2 to 9, 2 to 9, and then we got 2 to 4. We got a g of x and a g of x. This can be written as 8 times the integral 2 to 4 of f of x dx, but we don't have 2 to 4 of f of x. We have 2 to 9. And we have 4 to 9, right? So 2 to 9 and 4 to 9, and we want 2 to 4. So if I have the integral from 2 to 9 of f of x dx, that's going to equal the integral from 2 to 4 of f of x dx plus the integral from 4 to 9 of f of x dx, right? I want to know what the integral is from 2 to 4 of f of x dx. I know the integral from 2 to 9 of f of x dx is 14. And I know the integral from 4 to 9 of f of x dx is 6. So what would this end up being the integral from 2 to 4? It would be 14 minus 6, which would have to be 8. Right? So the integral from 2 to 4 plus the integral from 4 to 9 is the same as the integral from 2 to 9. So this ends up being 8, and I have 8 times 8, which is 64. So it turns out you don't use the g of x at all. So the integral from 2 to 4 can then use the fact that you know the integral from 2 to 9 and break that up from 2 to 4 and 4 to 9. You were given that information and you can find that this would have to be 8. Use the definition of the definite integral to evaluate this. So we're going to have to use the fundamental theorem of calculus here because we don't have a line, so we can't do geometry. So the integral from a to b of f of x dx is going to be the antiderivative evaluated at b minus the antiderivative evaluated at a. Sometimes people write that as the antiderivative and then they put a bar like this, kind of for shorthand to get this. So going through this, I have the integral from 0 to 4 of x squared minus 3 dx. So I have to find the antiderivative. So the derivative, I need a function where I take the derivative of the function and get x squared. You can know the power rule, and that's going to be, I'm going to add a power and then divide by that power. So if I take the derivative of x cubed divided by x cubed divided by 3, I would have 3x squared over 3, and the 3's would cancel, and I'd be left with x squared. So I have x cubed over 3 minus the integral of 3, which would be 3x. And I evaluate that at the upper bound of 4 minus the lower bound of 0. So in this case, I have 4 cubed over 3 minus 3 times 4. And I'm going to subtract that from 0 cubed over 3 minus 3 times 0. So I would have, this would end up being 64 over 3 minus 12. Minus this whole thing goes to 0. So I would end up with 28 over 3. Number 17, graph the following functions. Use geometry to find the area and whatever square units would be. So you found the correct graph here. If I blew it up here, I didn't. And I'm going to integrate it from 0 to 9. So if I plug in 0, I would have minus 6. So that tells me the distance is from the x-axis is 6. When does 2x minus 6 equal 0 for y? So I'm trying to find the point where it crosses the x-axis. So 2x minus 6 equals 0 when 2x equals 6, when x equals 3. So this distance would be 3. And then 3 to 9 gives me the distance of 6. And then if I plug in 9, 2 times 9 minus 6 would give me 12. So for the area, I have to keep in mind it's going to be 1/2 3 times 6, but that's going to be negative because it's below the x-axis, right? Plus 1/2 6 times 12, and that's going to be positive, it's above the x-axis. And I end up with minus 9 plus 36. So 36 minus 9 would be 27. You can use the fundamental theorem of calculus here as well, and you're going to integrate 2x minus 6 with respect to x from 0 to 9, and you can end up with the same answer here. If I do the 2x squared over 2 minus 6x, simplify that to x squared minus 6x. The upper bound is 9 and the lower bound is 0. I have 9 squared minus 6 times 9 minus 0. So 9 squared minus 6 times 9 and I end up with 27, which is the same answer there. So this graph gives you the area of 3 shaded regions, and it asks you to find the area with you plugging in -2. So the area of x is going to be -2 to f of t dt. F of x equals 4 to x of f of t dt. So we're kind of looking at the same graph, depending on if we want a or f. So for a of -2, this is saying -2 to -2 of f of t dt. That's 0. Anytime you integrate a to a, then your area is going to be 0. If you're looking at this one, and I want to go to 8, so I'm going to take the integral from 4 to 8, I'm looking at this area. Well, it tells you the area is 9, but in terms of the integral, it's actually going to be -9, because it's below the t-axis in this case. On C, we're looking at a of 4, which would be the integral from -2 to 4 of f of t dt. So if I look at the graph, I'm going from -2 to 4. So I'm looking at this area. Both of them are above the t-axis, so I'm going to add them. 18 plus 9 would give me 27. F of 4, again, is going to be 4 to 4. So in this case, f of 4 is going to be 0, because when you integrate the same points, you're going to have a 0 area. And a of 8. So a of 8 ends up being the integral from -2 to 8 of f of t dt. So I go -2 to 8. So I would have a positive 9 plus 18 minus 9, which gives me 18, because this would be a -9 because it's below that t-axis. 3.5. Evaluate the integral using the fundamental theorem of calculus. Discuss whether your results are consistent with the figure. So looking at this figure here, this is a full period. So we're assuming that this area is the same of this area. And so we would expect the integral to be area 1 minus area 2 equals 0, if area 1 equals area 2. So going through the fundamental theorem of calculus, the integral of sine of x with respect to x is minus cosine of x, and the integral of cosine of x is minus sine. Okay. So if I integrate sine, I get minus cosine. If I integrate cosine, I get minus sine. And I plug in my upper bound minus my lower bound. So I'm going to evaluate minus cosine of 7 pi over 4 minus sine of 7 pi over 4 minus the quantity minus cosine of minus pi over 4 minus sine of minus pi over 4. You can see here we've got a lot of negatives kind of going around here, so we want to be pretty careful how we evaluate this. So cosine of 7 pi over 4 would be minus square root of 2 over 2. Sine of sine of 7 pi over 4 would be minus square root of 2 over 2. Just kind of hold this here. Cosine of minus pi over 4 would be square root of 2 over 2. The negative goes there. Minus sine of pi over 4, which would be square root of 2 over 2. So what do we have going on here? I have minus, minus, a minus, so this would be 0. Here I would have minus square root of 2 minus the square root of 2. See if I lost the negative there. Sine of minus pi over 4. Which would this end up being, drop the negative, minus square root of 2 over 2. 7 pi over 4 is the same as minus pi over 4. If you remember, this would be 2 pi. So if I go all the way around to 7 pi over 4, that's pi over 4 short of 2 pi, which would also be the exact same thing as minus pi over 4. You don't even necessarily need to evaluate it. You have minus cosine of 7 pi over 4 plus cosine of minus pi over 4, which is going to be the same thing, minus sine plus sine. So exactly what we would expect here. The area is 0. So using the fundamental theorem of calculus, it gets a little crazy, but this is one full period. So the area above the x-axis is going to be the same as the area below the x-axis. 5.3, number 7, is if I rewrite this using using powers, it's going to make maybe the fundamental theorem of calculus a little bit easier to evaluate. So I'd have 7x squared over 2 plus x. I'm going to add 1, so it's really 3 over 2. So 3 over 2 divided by 3 over 2. It's a little annoying when we deal with fractions, but nothing we can't handle. And I plug in the upper bound minus the lower bound. So I have 7 over 2 x squared plus 2 over 3 x to the 3 over 2. I'm going to plug in 4. So 7 over 2, 4 squared plus 2/3, 4 to the 3/2 minus 7/2 plus 2/3, because I'm plugging in 1. So what do I end up getting here? 7 over 2 times 4 squared is 56. And then we have 2/3 times 4 to the 3/2, which would be 16 over 3. 4 to the 3/2 would be the square root of 4, which would be 2, and then 2 cubed, which would be 8, and 8 times 2 is 16. So we have a fraction. 7 over 2 plus 2 over 3 be minus 25 over 6. So 56 plus 16 over 3 gives me 184 over 3 minus 25 over 6. Oops, 25 over 6. Plug it on your calculator, we get 343 over 6. So would be our answer there. A little tedious, but hopefully using your calculator, just be very careful your order of operations and how you go about doing things. You want to subtract this. But if you drop your parentheses, a lot of times students miss this negative. Find the area of the region bounded by the graph of sine of x on the x-axis from minus pi over 3 to 5 pi over 6. Right? So if we go and graph sine of x, we we end up with so if we're looking for minus pi over 3 to 5 pi over 6, we're going to just have to do the integral of sine of x with respect to x from minus pi over 3 to 5 pi over 6. So the integral of sine is minus cosine. And then I'm going to plug in the upper bound minus the lower bound. So again, with the negatives, you got to be a little careful. Minus cosine of 5 pi over 6 minus cosine of minus pi over 3. So evaluate cosine at 5 pi over 6. And that gives me minus square root of 3 over 2 plus cosine of minus pi over 3, which would give me 1/2. So that gives me 1/2 plus square root of 3 over 2, which gives me 1 plus square root of 3 over 2. The integral of sine, hopefully these are helpful. If you want to meet again tonight, just let me know and we can set that up.